Hello, ladies and gentlemen. Welcome once again to our virtual classroom. And today we're going to be going over SB 4-3, which is mixed numbers. Mixed numbers, as you can see here in the heading. So I do recommend that you pause this video. Please copy down this heading, the page number. This is our 8th lesson. And please make sure you copy down the numbers that we will be doing in our assignment. Some of these are numbers that we will actually use as examples within our lesson, but please copy these down. Numbers 1 through 3, so numbers 1, 2, and 3, and then numbers 6 through 9. So that's going to be numbers 6, 7, 8, and 9. Good. Okay. So again, today we're going to be talking about mixed numbers. And the question is, well, what is a mixed number? Essentially, a mixed number is whenever you're mixing a whole number and a fraction to express a quantity or something. For example, right here I have 1 and 3/10. So as you can see, I have 1 whole and I have 3/10, which is a fraction. So I have a whole number mixed with a fraction. That whole number can be 2, 4, 100, as long as it's a whole number, meaning a number without a decimal value. And the fraction represents the part. So 1 whole and a little bit more is what we're saying when we have a mixed number. So again, it's mixed because I'm mixing the whole numbers and a fraction. And so what might 1 and 3/10 actually look like? Okay, well, as usual, let's begin with the analogy of a pizza. And so I have pre-drawn 2 pizzas here. And so if I have 1 whole pizza, that is 1 whole pizza. So we have every single slice in that pizza here. And I've decided to cut these pizzas into 10s for simplicity's sake. But if I have all 10 slices in a pizza that is cut into 10 pieces, then that is 1 whole pizza, which is the same thing as having 10 out of 10 slices, okay? So I have 1 whole pizza, 10 out of 10. Very good. However, not only do I have 1 whole pizza, but I have 1 whole pizza and a little bit more. I'm gonna have 1 whole pizza and 3 extra slices. Maybe this was leftovers from a get-together that you had at a party with your friends at Peter Piper or whatever it is that you young kids do nowadays. But yeah, so this would be the leftover. So you have 1 whole pizza left over and then another not whole pizza, but 3 pieces on top of that, 3 out of a total of 10 that you would need to make a whole. So that's where we get 1 and 3/10. So we literally have 1 whole pizza, which is up here, and the 3/10 of a pizza, which is down here. Now, if this was cut into 8s, then I would have 8 out of 8, so that would be 1 whole and 3/8. But that is not the case because I cut my pizza into 10ths, so 1 and 3/10. So that is a mixed number, okay? The thing about mixed numbers, though, is that they can also be expressed in what may seem like a more traditional way as a fraction with a numerator and a denominator, okay? So we can actually change this mixed number into a fraction, specifically an improper fraction, by following what I like to call the Texas method, okay? Where literally you just have to remember, well, what state do we live on? Well, we live in Texas, so I'm gonna draw a T and then X right between the whole number and the fraction, so TX. The T will stand for addition and the X will stand for multiplication. All right, so that's just reminded me of what I need to do in order to change this mixed number into an improper fraction, and that is that I need to multiply the denominator times the whole number. So 10 times 1, which by the way gives me 10. So I'm just gonna write up here to remember. So 10 times 1 is 10. And then whatever answer I got, so I got 10, I'm going to add the numerator. So 10 plus 1 is 13. So that's gonna give me 13, and we keep the same denominator, 13/10. Now notice how I'm using an equal sign here, meaning that these 2 quantities are exactly the same thing. 1 and 3/10 is the same thing as 13/10. And again, just to review it a little bit, let's do that one more time. So again, if we have the mixed number 1 and 3/10. I can change that into an improper fraction by doing the Texas method, so TX, wherein I'm going to multiply the 10 times the whole number, 10 times 1 is 10, and then I'm going to add the 3, so 10 plus 3 is 13, so that would be 13/10. But what, yes, okay, Mr. Lugo, they're the same thing, but what does that actually mean? Well, again, let's go back to our pizza example. This was 1 whole pizza plus 3 other slices out of 10 that I need. If I had all 10 slices, then this wouldn't be 1 and 3/10. This would be 2 pizzas, right? But it's not 2 pizzas, it's 1 and 3/10. How about instead of counting the whole pizza, let's just count the slices that we have. How many total slices do I have? Well, let's count. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, obviously 10, that makes total sense, 10 out of 10, 11, 12, 13. So really, I have 13 slices out of 10 that I need to make a whole. So obviously I have more slices than what I need to make a whole. That's why the numerator is larger than the denominator, but we can see that these are both representing the same thing. The mixed number is showing me how many wholes I have and then what I have extra, so 1 whole and 3/10, whereas the improper fraction is showing me just the number of slices I have, the number of pieces, out of how many of those pieces I need to make a whole. But again, these are two sides of the same coin. They are representing the same amount. They're just from a different perspective. So again, a mixed number can be changed into an improper fraction by using the Texas method. We multiply the denominator times the whole number, and then whatever answer you got, you add the numerator, and that's how I got 13/10. So we've gone from a mixed number to an improper fraction, but is there a way to go from an improper fraction back into a mixed number? And the answer is, of course, yes. How do we do that? Well, let's begin with the same quantity that we had with. So 13/10. So let's start with that right there. So 13/10. And here we just have to remember that anytime you have a fraction literally means divide. It's division. 13 divided by 10, the top number divided by the bottom number. The top number goes inside, right? Just like we have seen in the past. So 13 divided by 10, so I'm going to take 13 divided by 10. So 10 goes into 1 0 times, but 10 goes into 13 exactly 1 time, or only 1 time. 10 times 1 is 10. We have a remainder of 3. Now, ladies and gentlemen, this is the only time in middle school where we really use remainders, and it's when we're working with improper fractions and mixed numbers, because I'm not going to keep going. I could bring down a 0 and find the decimal amount, but no, I'm going to stop right there. And I'm going to ask myself, again, how many times did 10 fit into 13? How many whole times? It fit 1 whole time, right? 1 whole time. So that 1 is my whole number. So 1, and then how many did I have left over? Or where's my remainder? 3, and we keep the same denominator. 1 and 3/10. Notice how we have the same exact denominator. And we just went back to the beginning. 1 and 3/10, 1 and 3/10. So again, let me recap what just happened. All right, so again, we have the improper fraction 13 over 10, which means 13. Oh, that is terrible. So we're starting with 13/10. That is still bad. And that is the same thing as 13 divided by 10. 10 fits into 13 only 1 time. 10 times 1 is 10. 13 minus 10 is 3. So 10 went to 13 exactly 1 whole time. So it's going to be 1 whole. And we have remainder 3, and we keep the same denominator, 1 and 3/10. We are back to the very beginning. Okay? Recap. Mixed number to an improper fraction, we use the Texas method, okay, where we multiply the denominator times the whole number, and then we add the numerator. I encourage you to rewind this video, go back to where I talk about that if you're still confused, or to watch the videos that I posted on resources, and we'll go over that in a second. And so by doing that, that's how I got 13 tenths. And the way that I go back from an improper fraction into a mixed number, you just divide 13 divided by 10. The answer on top is the whole number, so 1, and then the remainder is the numerator 3, and then we keep the same denominator, 3 tenths. Very, very good. Okay, moving on. As an example, we have number 6, which is one of our homework problems. I realize I'm not starting with number 1. I hope that doesn't drive anybody crazy. But let's change 3 and 1/4. Let's change 3 and 1/4. Let me make this a little bigger. 3 and 1/4. So let's change this mixed number. Notice how it is a mixed number. I'm mixing whole number in a fraction. Let's change this into an improper fraction. So I'm going to use the Texas method. So I'm going to multiply 4 times 3. So 4 times 3 is 12. 12 plus 1 is going to be 13. So this is going to be 13, and we keep the same denominator, 13/4. These are exactly the same. So this would be the answer to number 6. How can I check it? Well, I can just go backwards. 13/4. Let's change 13/4 into a mixed number again by dividing 13 divided by 4. 13 divided by 4. 4 goes into 1 0 times, but 4 goes into 13 3 times. 4 times 3 is 12. The remainder of 1. So it fits 3 whole times and 1/4. That is the exact same thing as what I have over here. This is correct. I just went back and forth. And again, if I went too fast, I encourage you to rewind this video. I don't want to take too much of your time. Number 7 is an interesting one, and I'm doing it here in the lesson because I like the example. Okay, so what we have here are 3 circles that I'm just going to call pizzas because, as you know by now, I am obsessed with that. And so we have 3 pizzas, and we're going to cut these into not 10 slices, not 8 slices, but into 4 slices. Okay, so having cut these into fourths, let's shade in 9 slices. Okay, so by shading in a whole pizza, because I cut them into fourths, I'm shading in 1, 2, 3, 4 slices. So that's 4 slices right here, because that's a whole pizza. 4 out of 4 is my full pizza. I'm going to shade in another 4 slices, so another whole pizza. So now I have another 4 slices shaded in, so that's 8. And I want to shade in 9, so now that I've shaded in 8, I just need to shade in 1 more slice. Now I have 9/4 shaded in. 9 slices shaded in over 4, because 4 is what you need to make a whole. Let's change this into, for 7b, let's change 9/4 into a mixed number. But not mathematically. Let's just ask ourselves, how many holes are shaded in? Well, we have this hole right here, so that's 1 hole. And here's another whole pizza, so that's 2 whole pizzas. So that's 2 whole pizzas. And I have 1 more slice out of 4. Because 1 out of 1, 2, 3, 4 slices. 1 out of 4 slices. And so right here, what we're saying, guys, is that 9/4 is the same thing as 2 and 1/4. 9/4. So 9 slices, 1/4 is what makes a whole, is the same thing as 2 and 1/4. Let's try this mathematically. Okay, let's divide 9 divided by 4. Let's change this and see if we get 2 and 1/4. So 9, and I'll do it on the side. 9 divided by 4. 4 goes into 9 twice. 4 times 2 is 8. Remainder 1. So that would give us 2 wholes. Remainder 1, and we keep the same denominator. 2 and 1/4. It is exactly the same thing. So hopefully this gives you an idea visually how, yes, an improper fraction and a mixed number can represent the exact same thing, just from a different perspective. The first, 9/4, tells me how many slices I have whenever 4 slices makes a whole. And the second, 2 and 1/4, tells me how many holes I have, 2 whole pizzas, and how much I have left over or extra on top of that. Okay? That's pretty much it, ladies and gentlemen. I hope that you found this video helpful. If you're still struggling with this, I do recommend that you go to Schoology, and having gone to Schoology, check out the videos that I posted under resources, under number 8, which is our 8th lesson, 4-tree mixed numbers and improper fractions. And I have one video that goes from mixed numbers to fractions and one that goes from improper fractions into mixed numbers. And so again, I hope that you find that helpful. And I will see you soon.